Okay, we have seen so far how to build this program, and it's quite simple actually. So how do we actually build the project is by clicking the project tab, and you can either select build all or you can select make. So the shortcut is keys here, Control F10 or F10, so either one will do. So let's compile and you can see the output. It should be quite fast, but sometimes it just takes some time. So build succeeded. See, there's no error. So what if our program has some errors? So we shall see how to troubleshoot. So let's say purposely I create some error here. Just type red file and red file, and let's say I just remove this 8 for example. So let us try to build this again. Project, and so now we have build fail. As you can see here, build fail. So how do we find where is the error? So here you have number of error and also warning. So let us see the first error, error 105. Usually the sequence is we give more priority to error statements compared to the warning statements. Usually sometimes when you settle the error statements, the warning gets settled by itself sometimes. So let us see the first one. It mentions here cannot open file, include file P1F458. If you are very much well versed in assembly language, then you can immediately know that there is a typo error here. The 8 is missing. Let's say you can't really find. So you want to locate where is this error. So you just double click on this on that error statement. I can see this blue arrow shows where the error contains. So you can try to look at this line and where is error, and you know that you need to include 8. So let us try to build again, see what happens. Again we have build fail, and what is the problem this time? Okay, we have this warning and error. Say found label after column 1, red file, address label duplicated or in different or in second pass. So that seems to be some problem here. So if you can just double click on this statement, and you can see it shows, it points to where is the error. So you know that, oh, this is the type of error, it's supposed to be FIE. So same thing goes here, it's FIE. So like that you should troubleshoot each line until you get a complete build succeed. So now it should be okay. Okay, the build succeeded. So the next thing what we want to do is we want to check whether this assembly code or this program, is it working according to our desire, is it working according to the requirement of the question. So in order to do that, we need to go into debugging mode. So how do we go into debugging mode? It's quite simple. There's a debugger tab on top here. Let's click that. You can see only two options: select tool, under select tool, you'll be choosing MPLAB sim because it's MPLAB simulator. So you click MPLAB sim, and you can see at the bottom here, now you can see it's written MPLAB simulation. You can see your PIC that you're using, and this is your program counter. It's actually 0, and this is the content of working register, still 0. This is the condition of your status register. This is the frequency that you're using. The current bank selected is bank 0. So you can see all these things here. This is only viewable, this can only be seen in MPLAB sim. So how we are going to start is, again you go to debugger tab. You need to reset the microcontroller. So you go under reset, then processor reset. The shortcut is actually F6. It would be good if you can remember this. So when you click processor reset, you can see the green arrow. This green arrow actually represents the program counter. So currently the program is pointing at address 0. So now we want to execute this instruction line by line. So we are going to use this option, step into, using F7. We don't want to use F9 because it will straight away execute the whole program. So you can't see how each line is being executed. So we're going to use F7. So before we start to execute this program, now this, as you all know, this program is to swap the content of hex 200 with hex 300. So these addresses are in data memory. So how can we actually view the data memory? So you go to the view. So here you can select file registers. So view file registers. So this is the content of your sorry, having a little bit problem with viewing my file registers. Okay, this is your file register or your data memory. So we are dealing with address. Let us minimize this. I have so much duplication. So close the rest. Put it side by side. So we are interested to swap the content of hex 200, which is here, the content of hex 300, which is here. So before we execute this program, let us put some value in these two locations. It's quite simple. Just double click on this location, and let's say I just type 22, just click enter. So you can see you can write some value to this location, address hex 200. So let us go to address hex 300. I'm going to type here, let's say 44. So you have 44 and 22. So when you execute this code, what you can anticipate is, okay, you expect the content of hex 200 and 300 to swap. So what we're going to do now is I'm gonna click F7. So when I click F7, you see the program pointer goes to the label start, because at the address hex 00 we have the instruction or the assembly directives to go to start. That's why the program counter is jumping to the label start. So now the PC is actually pointing at the first address, at the first instruction. Now this, when it's pointing here, it means that it has not executed this line yet. So what do you expect this instruction to do? It will move the content of hex 200 to working register. So what is the content of hex 200? It is 22. So when you press again F7, you can see this line will be executed and your program counter points to the next one. So you can see here below in working register you have hex 22. And the next line is moving the content of hex 300, which is just now is 44, to hex 200. You move FF, so you can see 44 have been copied here, and you can see at 300 it's still 44. The last line is supposed to move the content of working register. Inside working register we have hex 22, so that's supposed to be copied to hex 300. So let's see whether it's happening or not. And there you have it. You can see 22 is here and 44 is here. So you can see that the content has been swapped. So this is how we actually run the debugging, how to check whether the program is working or not. So the next thing that we can do is, there's another function that will be very helpful. If you go under view, there is this watch function. So if you click this watch function, you can actually use this watch function to monitor any special function register. So in this case, in our program, the only special function register that we are using is working register. Actually, for working register, you do not have to use the watch function because you can see the content of working register here itself. But just to show an example, so how do we use this watch function is you click on the drop down menu, you type W and you can search for working register. So you click working register and then you add special function register, and you can see that you can view the address of the working. Of course, if you expand this, you can see the address of the special function register, the symbol, and also the value inside the working register. So you can use this watch function to actually monitor or to see what is happening to the content of the special function register. So this will be quite useful to monitor any other special function registers besides working register. So this is one function that you can use. And under the view tab, you can also view the program memory. So this is your program memory. So if you see at the bottom here, you have three types of tab. Opcode hex shows the hex code of the program memory. Machine code shows you the machine code, and if you use a symbolic, it will also include the label portion. So I would recommend all of you to use the symbolic tab. Here you can see how is your assembly code is arranged, and you can see the address. Each address you can see monitor here, and if you start to execute, let's say now F6, then if you press F7, you can see at address 00 you have this code. This opcode actually represents this assembler directive, which means go to start. So when you press F7, you can see the start label is here and another label is here. It works in pairs. So immediately go to start means your PC will go point at start. So because the start label and the first instruction is actually at address 001A, and you can see your PC actually pointing at address 1A. This start label actually it works like a tag. It actually it actually refers to address 001A. So if you press F7, it will go to the next instruction, and if you again press F7, it will again go to the next instruction. So you can also see the opcode. So sometimes if you want to check What is the opcode of move FF hex 200 to working register? This is the opcode, or the hex machine, or the hex code, or the machine code. So this is the instruction in hex, instruction code in hex C200 and FFE8. Similarly, it goes same with move FF hex 300 to 200 also. So now using all these functions, I believe that it will be very useful for all of you to actually analyze your program and debug your program and learn how the program actually works. So this is actually the end of MPLAB tutorial part 2.